Hey guys, welcome back to the On Centerline podcast. And if you're watching on YouTube, the Northwest Aeronaut YouTube channel, I am Sam Terrell, the Northwest Aeronaut. Thank you for joining me. It's been a few weeks since we put something out on the podcast and a YouTube video, but we're diving back into some more instrument flying today, where we're going to be discussing attitude instrument flying and the techniques and methods that are used for attitude instrument flying. All right, so yesterday I was doing a ground session with one of my many instrument students. I'm lucky right now. I've got like 5 different instrument students, and they're pretty much all in the same phase of training as well. So that's made it easy to keep everyone kind of on the same page. But I was talking to my student, Wendy. Shout out to Wendy Bird. And we were having a great discussion about attitude flying and the different techniques that we can use to do it successfully. Now, if we look in the instrument flying handbook, you're going to see 2 methods mentioned. The 2 methods, and I'll just read straight from the instrument flying handbook here. It says, the 2 basic methods used for learning attitude instrument flying are control and performance and primary and supporting. It goes on to say both methods utilize the same instruments and responses for attitude control. They differ in their reliance on the attitude indicator and interpretation of other instruments. All right, so first of all, keep in mind that when it comes to these 2 methods and how they're used, how they should be used, you're going to get a lot of different discussion from a lot of different people who have different opinions on the methods. And so just being upfront, this is just one of those discussions that happens to be based on my own personal experiences and opinions. So I'm not saying that if you do things slightly different than what I'm going to talk about, or you've been taught differently or anything, that it's wrong. This is just how I approach these 2 methods, how I teach them, and what I've seen to be most successful for me and my students. So we're going to start with I'm going to start talking about the primary and supporting methods. So when it comes to primary and supporting instruments, this method is primarily structured around the idea that you don't have an attitude indicator. Now, with all of my students, I, from the start, and this is basically how the FAA kind of recommends you teach instrument flying, but from the start, I try to inhibit or just, I want to take away reliance of my students on the attitude indicator. Okay, I don't want them to be relying solely on the attitude indicator, and especially with our G5s that we have in our aircraft. You know, if you have a true PFD, that's one thing, because first of all, it's a little wider, a little bigger. You still kind of have to move your eyes around. But when you have a 6-pack that's just been supplemented with a G5 or something equivalent, it's too easy to get fixated on that attitude indicator, because that's essentially what it is, right? A G5, yes, it shows you altitude and airspeed and rate of turn and turn quarter. It shows you everything, right? Just like a PFD would. But you got to keep in mind that it is only certified and intended to be used as a primary instrument for the attitude indicator in that case. So what I see happening all too often is instrument students and pilots fixating on that G5 because, 1, it's comfortable to be looking right at the attitude indicator, and 2, because all the information is kind of there on that one instrument. The problem is, if you get too used to just looking at that one instrument, your scan doesn't develop across the other instruments in the 6-pack. So the day that attitude indicator goes away, you are kind of stuck. You're not in the practice of scanning the other instruments, being able to use primary and supporting instruments, and using our cross-check and our instrument interpretation to successfully fly in that partial panel environment. So typically from the start, I am taking away that attitude indicator and working solely on kind of partial panel skills where we are having to move our eyes back and forth from airspeed to altitude to vertical speed and directional gyro and turn coordinator, because that's really the way you're going to build those skills of learning to cross-check instruments, building that scan, and then learning how to interpret those instruments to be able to successfully fly the aircraft in an instrument environment. I always relate it to the Matrix, right? We see in the Matrix the guy sitting at the computer and it's just a bunch of green symbols and things falling down the screen, and yet to them, they see everything that's going on as if they're just watching a movie. Well, it's the same thing with instrument flying. When you start out, you're looking at all these gauges and dials, and it might seem like the Matrix, just a bunch of symbols and things happening. You don't really know what it means. It just looks like gibberish. But over time, as you develop your skills and you learn the scan and the proper cross-check and interpretation, all of a sudden the image starts kind of developing right in front of your eyes, and you can basically see everything that's happening just as if you were looking out the window flying in the visual environment. And that's ultimately the goal that we are kind of working towards through instrument training, is to have you be able to interpret and apply your flying skills, interpret what you see on those instruments the same way you interpret signals when you look out the window at the actual horizon. So when it comes to primary and supporting instruments, the instruments that are primary and the instruments that are supporting are going to fluctuate and change kind of based on what you're trying to achieve in a given phase of flight. If we're flying straight and level, you'll have certain primary and supporting instruments. And then if we're trying to initiate a climb or descent, your primary and supporting instruments might change. Same thing if we initiate a turn in either direction. And so your scan is going to kind of reflect this. Now, when we do have an attitude indicator in a normal full panel operation, the scan I teach is just what I call the T scan. It looks like a T. This is a variation of what you might have heard referred to as kind of the wheel and spoke model or the radial model, where basically everything starts at the attitude indicator and moves out and back to the attitude indicator from there. So we move in a T, starting at the attitude indicator, going over to our airspeed, back to our attitude, over to altitude, back to attitude, and then down to your heading indicator and back. And then we kind of throw in, every once in a while, a look at our turn coordinator, and then a look at our vertical speed as necessary. But for the most part, we're kind of just moving in this T shape with our scan. Now, that works great for straight and level flight, because we should be looking at our attitude, of course, referencing our altitude to make sure we're not changing altitude, looking at our heading to make sure we're not accidentally turning, and making sure our airspeed is consistent. Now, when we begin a climb, well, then we want to shift our focus a bit, and I end up kind of using an upside down L. So it'd go from the attitude indicator over to our altitude indicator, down to our vertical speed, okay? And then back up, and then attitude and over to our airspeed. Depending on if you're focused on your airspeed or your rate of climb when you're doing this climb, or descent for that matter, you might shift the way your scan moves. But for instance, if we are looking to do a constant airspeed climb, we might start at our attitude indicator, move over to our airspeed, then back to our attitude, and then cross-checking with our altitude down to our vertical speed, and kind of making that upside down L, kind of that Tetris shape scan going across the top and down to the vertical speed. Now, when we need to make a turn, my scan is going to shift and create kind of a backwards L, going from our attitude indicator down to our heading indicator, over to our turn coordinator, and back to the heading indicator, and then back to attitude. So we're moving down, over to the left, back to the right, and up, kind of with that backwards L shape. All right, so these are just the different scans I use for different phases of flight. So when we're talking about our primary and supporting instruments, well, Let's say we take away our attitude indicator, because assuming we have an attitude indicator, and this is kind of where the guidance from the FAA is a little bit off, and I disagree with some of the things they put forth. But if you have an attitude indicator, that should kind of always be one of your primary instruments for pitch, right? But let's take away the attitude indicator. If our attitude indicator goes away and we need to just maintain straight and level flight, well, what primary instruments are we going to be using? Let me pull up here our little chart. All right, so for those of you watching on YouTube, I put this chart up on the video, but I'm just going to talk through it here and talk through what I agree with and what I don't agree with. For straight and level flight, it says our primary pitch instrument is going to be our altimeter, okay? And that makes sense, right? We just want to make sure we're not changing altitude, so we're going to be looking at that altimeter for that. Our supporting instruments for pitch, it refers to our attitude indicator and our vertical speed. Now, like I said, we're going to take attitude indicator out of the equation for this, because if you had your attitude indicator, this is where I kind of disagree here. If you have your attitude indicator, that should kind of be one of your primary, along with your altimeter, right? I mean, there's different ways to look at it, but we're going to take it out of the equation. So, supporting instruments that I would be using for pitch would be your vertical speed, of course, as well as your airspeed indicator, which isn't mentioned here. Now, your primary for bank, we just want to make sure we're straight and level, therefore we're not turning. It says to use your directional gyro or your heading indicator as your primary. I get that, and I can get on board with that for straight and level flight, but equally as important, realistically, is your turn coordinator or your rate of turn indicator showing your bank into a standard rate turn. It has that as a supporting instrument here, your turn coordinator. And the reason why I don't necessarily agree with that is because, think about this, if we don't have an attitude indicator, what would be the reason why we don't have an attitude indicator? Chances are it's because we had a vacuum failure. And what other instrument fails with a vacuum failure? Your directional gyro. All right. So I know they're including the attitude indicator in this, but assuming we don't have an attitude indicator, we're going to assume we probably don't have a directional gyro. So having that as a primary instrument for bank doesn't make a lot of sense in that case. So I would personally kind of use that turn coordinator as a primary instrument for bank. And then if you do happen to have some sort of heading indicator, that can be a supporting instrument. All right, looking at our constant airspeed climbs and descents. Your primary instrument for pitch is going to be airspeed, right? We're going to set a certain airspeed for that climb or descent. We're going to maintain it. Then as a supporting instrument, we are going to be, it talks about using your attitude and vertical speed, taking away the attitude, vertical speed, and for me, the altimeter would be a supporting instrument as well. Because of course, if you're climbing or descending, you're probably going to have a certain altitude you are climbing or descending to, and you're going to want to reference that on the altimeter. Primary for bank and a climb or descent is still, for me, your turn coordinator supported by your heading indicator. Now, when we move on to constant rate climbs and descents, we're going to be using our vertical speed for our primary instrument. And that makes sense. Here's the one caveat and thing you might need to think about. You know, it doesn't matter if we're talking VFR flying or IFR flying, any type of flying. When you look at the rules for required equipment in any of these types of flying, there is only one instrument that never ever gets mentioned as being required, and that's your vertical speed indicator. So a vertical speed indicator, funny enough, is not required for any type of flying, let alone instrument flying. So it is possible, although not probable perhaps, but possible that your airplane does not have a vertical speed indicator, at which point, you know, obviously it can't be used as a primary or supporting instrument. But in general, we're going to use that as our primary for a constant rate climb or descent, supported for me by the airspeed indicator and, of course, the altimeter. That's not what you see here on this chart, but that's just how I differ. And then finally, when it comes to turns, standard rate turns, of course, your primary for pitch, They say altitude, and I can get on board with that. Making sure your altitude doesn't move, of course, is going to help ensure that you're not climbing or descending, unless you're trying to do a climbing turn or descent. That's where it gets a little different. But for a level turn, we'll be looking at that altitude for pitch, supported by our vertical speed and airspeed. And then our primary bank indicator is going to be our turn coordinator, okay? Followed by or supported by our heading indicator if we don't have that attitude indicator, okay? So you can see how, for those of you watching on YouTube, you can see how my personal preferences differ a little bit from what's listed here. But hopefully that makes sense to all of you out there, and you see how, based on the phase of flight you're in and what you're trying to achieve, the primary and supporting instruments can change. Now, again, going back to if we have an attitude indicator, that should always kind of be our primary instrument for pitch and bank. And we're going to get more into that here in a second. But, I mean, it is called attitude flying for a reason, right? And the attitude indicator is the only direct and immediate reference to the airplane's attitude that we have. So that's where the next method of instrument flying comes into play, which is the control performance method. And this is really the way that I ultimately fly instruments, and that I teach to fly instruments, with that primary and supporting method still applying, but not at the forefront, okay? The primary instrument and supporting instrument method is, like I said, particularly useful and important in the partial panel environment when you don't have an attitude indicator. But in normal circumstances, and especially these days where we don't really have vacuum systems as much in airplanes anymore, they're all digital, and we have a lot of redundancies to where losing an attitude indicator is almost next to impossible these days. So, control performance method breaks our instruments up into two categories, basically control instruments and then performance instruments. Now, I add, there's a third category, which the FAA kind of refers to as your navigation instruments, and that is true. And I kind of refer to this third category as the status instruments, okay? So let's talk about these control performance method and the different instruments. When we are talking about our control instruments, they are the instruments we're using to see and gauge a certain amount of input that we are making on either the flight controls or on the power of the aircraft, okay, the power setting. So our two primary control instruments are our attitude indicator and our tachometer, or your manifold pressure gauge. There could be other instruments, especially in more complex aircraft, that you might consider to be control instruments, like fuel flow or things like that. But for our GA world and in general, our tachometer / manifold pressure, along with our attitude indicator, are our control instruments. So when we make an input on the yoke, we can see a certain either bank or pitch change in our attitude indicator. And it has markings, of course, on that attitude indicator that show us the amount of input we're making, whether we're pitching down 10 degrees or up 10 degrees or banking left 15 or 20 degrees or right 30 or 45 degrees, right? So these are measured inputs that we can gauge and track. And then we have our power control instruments. So for instance, just in our 172s, we have our tachometers that show the RPM of the engine. And of course, we can manipulate that with our power. So we can set a certain power setting. And as we know, pitch plus power, or some people say attitude plus power, equals performance. So these control instruments, our attitude indicator plus our power, when we add those together, it gives us our performance. And where do we see that performance when we're in the instrument environment? We see it on our performance instruments, okay? So what are our performance instruments? Well, basically, they are all the other gauges on our 6-pack. There are airspeed, there are altimeter, our vertical speed, our heading, and our turn coordinator. These are all performance instruments. They're going to react to the inputs we make, and they're going to show us the result of those inputs, or the performance, okay? So when we are trying to, say, fly an ILS approach, okay, a precision approach and follow glide slope, there is going to be a certain pitch and power setting for your aircraft that's going to nicely establish you on that 3-degree glide slope. And kind of mapping out and knowing different pitch and power combinations for a given result throughout all phases of your flight is a very useful and important tool for you to have, not just as an instrument pilot, but as a pilot in general. So if you have not yet mapped out different settings and different pitch attitudes for a given performance in the airplane you're flying, I highly recommend you go out with your CFI and you guys spend some time figuring out, what does this power setting with this pitch attitude get me for my rate of descent, okay, or my rate of climb? So in general, for like our Cessna 172, we might set 10 degrees of flaps. We might put our power at 1900 RPM and pitch down about 4 or 5 degrees to maintain about 90 knots on a final approach, ILS, for that 3-degree glide slope. Okay. What's really cool about the Cessna 172 is when you do have 10 degrees of flaps in, it just so kind of happens that for every degree of nose down pitch you do at 90 knots, okay, we're flying in at 90 knots. Well, for every degree of nose down pitch, you get about 100 feet per minute in rate of descent. So if we want to hold a 500 foot per minute rate of descent, all we have to do is put the nose down 5 degrees. If that ends up being too much and you say, hey, I need a little bit less, maybe 450 or 400 feet per minute, then you just bring that nose up 1 degree to 4 degrees, and that'll give you your 400 feet per minute. Now, this isn't going to be the same in all planes necessarily, and it's not even the same in a 172 if you were in a different configuration, like no flaps, okay? But with 10 degrees of flaps in a 172, it tends to work out about like that. But whatever it is in your plane, you kind of want to figure that out. And then when it comes to flying the glide slope, our general rule of thumb for calculating the rate of descent is to look at our ground speed. Let's say our ground speed is 90 knots, okay? There's one of 2 ways you can do this. There's 2 ways you get the same answer in both cases. Certain people's brains work differently, and it might be easier for you one way or the other. But you can either take that ground speed of 90 knots, divide it by 2, which will give you 45, and then add a 0 to it, which is 450. So at 90 knots, a descent rate of 450 feet per minute should hold you more or less on a 3-degree glide slope. The other way to do it is just to simply take the ground speed, multiply it by 5. 90 times 5 is 450. You get the same answer. So whatever works easier for you, go with it, but that's the rule of thumb. So 90 to 100 knots of ground speed is going to give you 450 to 500 feet per minute, which is pretty standard for an ILS approach. So let's look at our control and performance instruments for flying this type of approach. Of course, our control instrument is going to be our attitude indicator and our tachometer. We're going to set our power setting for about 1900 RPM. And then with our attitude indicator, we're going to make sure we're holding the proper attitude, which again is going to be about 4 to 5 degrees nose down based on your ground speed, okay? So we're going to just set that pitch attitude, let's call it 5 degrees nose down, with the proper power setting. Then we need to cross-check our other instruments, our performance instruments, to make sure that the result we're getting matches our desired result. So first, what are we going to look at? We are going to look at our rate of descent, at our vertical speed indicator, okay? So our control instrument in this case is our attitude indicator. Our performance is going to be our vertical speed first and foremost. Looking at that vertical speed, if we have 5 degrees nose down, we would expect or be looking for 500 feet per minute. Okay, assuming that that is correct and it's looking right around that point, we know we have successfully configured the aircraft for what we need it to do. Then we're going to cross-check our airspeed because we do want to maintain about 90 knots on the approach, give or take. So we're going to make sure we're right around 90 knots because, of course, if your airspeed changes, your ground speed is going to change as well. Your given ground speed is always going to be a result of whatever your airspeed is, true airspeed technically, based on what the wind's doing, okay? But if we're flying at an approach of 90 knots, it's generally going to be 90 knots or slower, assuming you don't have a tailwind. So 450 or so, maybe 400 feet per minute is what we need to hold. And so let's say we were holding that 500 feet per minute initially. Well, we need to know that that is the performance we wanted, right? We put our nose 5 degrees nose down. We looked at our vertical speed. We saw 500 feet per minute. That's exactly what we wanted. But now we need to look at our navigation instrument, which is our glide slope indicator. And we need to make sure that that control and performance combo is actually getting us the result we want, which is staying on the glide slope. If we see that glide slope creeping up, in other words, we are going below it, we know that that rate of descent of 500 feet per minute is a little too much. So what do we need to do? We need to raise the nose maybe just 1 degree up to 4 degrees, confirm that we get the performance we want on our vertical speed of 400 feet per minute, and then we just hold it there, okay? Now, here's something to consider. One of the most common errors in instrument flying is chasing needles, okay, or overshoot, over-controlling, chasing courses, chasing glide slopes. What tends to happen is people get low, so they pitch up too much, and they try to climb up to the glide slope to re-intercept it. If you are on a glide slope coming down to a runway, at no point should you ever be climbing, okay? At the very maximum, if you are below the glide slope, all you should be doing in that moment is leveling off, holding the altitude you have and allowing the glide slope to come to you, okay? I always relate it. I related it to Wendy yesterday. I said, if you were trying to catch a fish with your hands, okay? You see these guys down in Mississippi doing catfishing or whatever, and they catch a catfish with their hands, and it's crazy stuff. But if you were going to try to catch a fish with your hands, would you just be jumping off the shore, you're seeing the fish, and you just jump and dive in at the water to catch it? I mean, you could try, but you would never catch the fish, right? That is never going to go your way. Same thing if you're trying to catch a glide slope. If you just dive at it or climb to it or just try to lunge at it, you will never, ever win that battle, okay? And you will never catch it. So, just like catching a fish with your hands, you should wade out into the water, be very still, get your hands in position, wait for the fish to come to you, and you just grab it when it's in the right position, and you hold on. That's the same way we want to capture a glide slope. You level off at a given altitude, you wait for it to come to you, and when it's in the right position, you grab it, and you hold on the rest of the way down, okay? So, that's if we're low on the glide slope. Now, if we are high on the glide slope, well, we do need to descend a little bit. So putting that nose down just an extra degree or two to increase that rate of descent should allow that glide slope to come back up. And then again, based on what your ground speed says, let's say it says 90 knots, we should be descending at about 450 feet per minute to hold that glide slope. So just keep in mind that if you are high on the glide slope initially and need to go down to catch it, it's going to require a rate of descent that's greater than 450 feet per minute for a short period, okay? So you might go down to about 6 degrees of nose down pitch, increase that rate of descent to 600 feet per minute until that glide slope comes back up and gets centered, then go back to your 400 feet per minute or 450 feet per minute. All right, so in this way, we are using our attitude indicator, along with our power, of course, as our control instruments. We are using the vertical speed as our performance instrument, and then we're almost kind of using, at the same time, the vertical speed as a control instrument for the glide slope, which is the performance instrument, right? We're getting we're manipulating the plane in a way that gives us a certain rate of descent, and then seeing the performance of that descent on the glide slope with our navigation instrument. So it's almost like a double whammy there. But I call the navigation instruments status instruments, right? When you think about a glide slope, when you think about a localizer, even when you think about altitude, or any type of navigational course that you might be on, these are all status instruments from the standpoint that they are showing you where you are at in that moment, okay? As opposed to what I refer to as trend instruments. Now, these are not to be confused with like trend vectors, trend vector indicators. Okay, certain PFDs and modern avionic displays have trend vectors like on your airspeed or on your altitude. That is not what I'm talking about. I'm just talking about instruments that show trends in general versus instruments that show the current state of your aircraft. So, an altimeter is a status instrument from the standpoint that it's only going to show you the altitude you're at in that moment. Now, yes, it has lag to a certain degree, but when you see that, you're at 6,000 feet, that's where you're at. However, the vertical speed I consider to be a trend instrument because it's showing you, hey, your altimeter might say you're at 6,000 feet right now, and that might be true, but you're going down at 200 feet per minute. So, basically every second that's going by, you are actually getting lower and lower, just hasn't registered quite yet on the altimeter, okay? Same thing with our navigational instruments. When we look at our localizer or our glide slope, those things are telling you where you are in space at that moment relative to a given signal or a given course, right? It's not necessarily telling you that you are following that course. It's just telling you whether you are on it or not, okay? So let's take a look at our localizer, for instance. It's great these days. We have technology that basically takes all the guesswork out of having to do wind correction and knowing what our actual track over the ground is. Thanks to GPS, most modern avionics have little wind indicators, little wind correction indicators. So on our G5s, there are these little magenta diamonds with a little dashed line that shows you your track over the ground relative to your heading. This takes all the guesswork out of following a course, any course, whether it's just an en route course or a localizer, because all we have to do is put that magenta diamond on top of the course we're trying to follow, and it will ensure that we track it true. Makes it very easy these days. Now, that magenta diamond is a trend indicator. It's telling you where you are actively going, right? The localizer itself is a status instrument, okay? It's telling you, hey, you're either on localizer, or maybe you're a little to the left of it or a little to the right of it. You can be on the localizer perfectly, but be actively leaving it if your wind correction angle, wind vector, is not lined up with that localizer. So often, one of the things that my students and just instrument students in general struggle with is they'll see the needle centered and perfectly aligned, but then they'll start letting that wind correction angle get off of that course, and they won't catch it until they see the actual localizer deviating. But by that point, it's too late. If that needle has deviated, you are off the localizer. So what we need to be doing is using that wind correction diamond as a kind of trend instrument to show us, hey, this is the direction you're going. If you keep holding this, you're going to be off course because you are actively going off course right now. It's just that the needle, the localizer, hasn't reflected it yet. Okay, so we need to make sure that that diamond stays right on top of that localizer course and that the localizer course stays centered. And if you do one, the other will follow. All right, so that's how we can follow the localizer. We don't quite have the same thing, the same equivalent for the glide slope, except for that vertical speed. So when we're trying to follow a glide slope down, what we need to do, and the nice thing about this, guys, is, and some of you will hate to hear this, but the nice thing is, this is just math. And it's not math that you need to fully know or understand. But the reason why I say that it's nice is because it is objectively true. And there's no interpretation behind it. When you have a 3-degree glide slope, it's going to take a specific rate of descent for a given speed over the ground to hold that glide slope. So the closer you can hold that proper rate of descent for the speed you're at, you don't have to worry about getting off glide slope. You will stay on it the whole way down. So what we want to be doing is we can use that vertical speed, and if we can lock in the proper rate of descent, 400 to 500 feet per minute based on our ground speed, that glide slope will not move. Okay? If it does happen to move, then just the small adjustments we talked about earlier should be an easy fix. But we got to make sure that we're not over-controlling. And again, the easiest way to do it, as I always say, if it ain't fixed, don't broke it. So if you're on the glide slope and localizer, keep that wind correction diamond on top of that localizer needle and keep that vertical speed pegged at the rate it needs to be at. You will not deviate all the way down that ILS. So these are the different methods we have for attitude flying, and the control and performance method is by far the kind of primary and easiest way to go about it. But understanding that we have these control instruments, we have the performance instruments that show us the result of the control inputs we made, and then our status instruments or navigation instruments that show us ultimately where we are in that moment. And then we can use these instruments in different ways. For instance, an altimeter is not what I would consider to be a trend instrument, but it doesn't mean you can't see trends on it. If you're seeing it go down, 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 well, that's a trend that you're descending, even though for any given moment, it's just telling you, hey, this is where you are or where you were, depending on how fast you're going. Same thing with the airspeed. The airspeed is a status instrument. It's showing you the speed you're going in that moment, but it doesn't mean you can't see trends with it as well. All right. So control instruments, performance instruments, status instruments, trend instruments, these are just terms that I use, and they can be interpreted in different ways or used in different ways depending on what you're trying to accomplish in a given phase of flight. But guys, that's just kind of a broad overview of how I teach attitude flying to my instrument students. Let me know what you guys think or how you were taught. Leave any questions here on YouTube down below, or send me some questions through the podcast if you have any. I really appreciate you spending time with me here today, and we will see you next time on Centerline.